Just the way we found out the derivative of the function fx equals to sin x, we need to find out in this video the derivative of the function fx equals to cos x. So how do we go about it? Any guesses? Essentially, again, what we need to do is use the difference quotient and then look at the limit. So the difference quotient in this would be essentially f of x plus delta x minus f of x whole upon delta x, right? So now f of x plus delta x would be cos x plus delta x, and cos x is the original function, so fx cos x. So this will be my difference quotient. Now, just as we applied sin a plus b, we need to now apply cos a plus b, because that's what I have here. This is a, this is b. Now, cos a plus b is a little different from sin a. Now, cos a plus b equals to cos a cos b minus sin a sin b. Okay, so it is different from sin in that manner. Okay, so cos a cos b minus sin a sin b. So I just substitute it out here. Cos x cos delta x minus sin delta x minus cos x upon whole upon delta x. Again, now what do I see out here? I see cos x comes in two terms out here, cos delta x and cos x. So cos x can be taken common, and what will remain in the bracket is cos delta x minus 1 upon delta x, or the change in x. And here sin x sin delta x upon delta x. So what I have done here is I have just combined delta x with the delta x term, delta x with the delta x term. Next step is again to take the limit as delta x tends to 0. So as delta x tends to 0, change in f upon change in x becomes cos x and this term minus sin x and this term. As delta x tends to 0, I just told you in the previous video, limit delta x tends to 0, cos delta x minus 1 upon delta x will tend to 0, and this term will go to 1. So what I will have is that this whole term becomes 0 and this term becomes minus sin x, and hence my derivative of cos x is essentially minus sin x with a minus sign.